In this section 2.6, graphs of basic functions, we're looking at, of course, graphs of our basic functions. In the next section following, we'll be looking at taking these basic functions and transforming them. Question number 1 asks us the following. Which one is the graph of the function y is equal to x squared? And what is the domain? Well, if you're not familiar with the basic functions, what you can do is set up a table and sketch some points. Let's look at x and y. And I usually start off with a couple negative values for x, 0, and a couple of positive values for x. And with those, I may have enough points to get an idea of what the graph looks like. So if I plug in -2 into the function where x is, y is equal to x squared. So -2 squared is a positive 4. Plug in -1 for x, -1 squared is a positive 1. Plug in 0 for x, you get 0. Plug in positive 1, you get 1. Plug in positive 2, you get 4. 2 squared is 4. Now we can translate those points to a graph. Graph paper helps here. And it also helps to clearly label your graph. These are your x values and your y values. 1, 2, 3, 4. And plot the points. -2 up 4. -1 up 1. 0, 0, 1, 1, and 2, 4. And you can actually keep adding more points to this. For example, if you plug in 3, you get 9. Plug in 4, you get 16. And you can keep plugging, and you'll see that this graph is going to continue up and up and up and up, going forever to positive infinity. And also the same way going to negative infinity. So this is our graph of our basic function y is equal to x squared. If you look at the choices given here, it looks like choice D, but you can actually zoom in. You can see over 1 up 1, over 2 up 4, and we're going to select D. Now we want to find the domain of this function. The domain is a list of all of the x values that you can plug in to this function. Okay, for the domain, these are all of the values that you can plug into the function. And notice that we plugged in negative values and positive values, and there are actually no restrictions on the domain here. If you look at the graph, the domain is described by the x values in terms of how far to the left is this graph going to go and how far to the right is this graph going to go. This graph is going to continue forever to the left, forever to the right. So the domain is actually all real numbers. How we write that using interval notation is by using the domain from left. Oops, go back, hold on a second. The domain goes from the left most x value that you can plug into the function to the right most x value that you can plug into the function. You can plug in negative infinity to positive infinity and every number in between. So we can write the domain as negative infinity to infinity, and whenever you have an infinity, you're going to use parentheses. I'm going to select the infinity sign from the palette and then check your answer. Question number 2 asks us to graph the function y, which is equal to the absolute value of x, and then find its range. Well, we can again make a table of values of f and y, x and y, where y is the same thing as absolute value of x. Plug in a few negative values, say -3, -2, -1, 0, 1, 2, and 3. When you plug that into the equation for x and solve for y, you get y is equal to absolute value of x. So the absolute value of -3 is positive 3, absolute value of -2 is positive 2, and so on. You get those y values by plugging them into the given, to the x value. Now with those, you can sketch the graph. By plotting those points, -3 up 3, -2 up 2, -1 up 1, 0, 0, 1, 1, 2, 2, and 3, 3. Connect those. You can keep putting larger and larger numbers in for x, and you'll notice that this graph is going to continue to increase, going larger and larger negative values. That graph is going to continue to go up in both directions. So this is our graph, and you can check the choices given here. It looks most like choice A. In fact, the absolute value graphs will most of the time look like either the top of an A or a V. Okay, now we want to find the range. To determine the range of the absolute value graph, we want to look at how low the graph goes and how high the graph goes when we want to find the range. The range is low to high. And also that corresponds to the y values. What's the smallest y value that you're going to get out of the function? And what is the largest y value that you're going to get out if you're looking at a table? You want to include all the possible values that you can plug in and look at what are all the possible values you can plug out. If you're looking at a graph, the way to determine the range is looking at how low the graph goes on the y-axis and how high the graph goes. This range here, the lowest that it goes on the y-axis is 0, and the highest that it's going to go is up to infinity. We put a bracket next to the 0 because the graph actually does touch 0, and then we put parentheses after the infinity sign. Let's check our answer here. Using brackets and the infinity, fantastic. For question number 3, we want to graph the function y is equal to x to the third power. We're going to do this a similar way, starting off by making a table of values of x and y. And I'll just start with a few negative points, a few values, negative values for x and a few positive values for x and 0. Plug those in, you get -2 to the third power is -8. -1 to the third power is -1. 0 to the third power is 0. 1 to the third power is 1. And 2 to the third power is 8. Do our best to sketch this graph. -2, -8 is a point. 1, 1, 0, 0, 1, 1, and 2, +8. Connect those. You get this graph. It looks like this. The graph is going to continue. If you keep plugging in larger and larger negative values, this is going to become larger and larger negative values towards -infinity. And if you keep plugging positive values in for x, it's going to keep going up and up the page. So if we look at the choices, the one that this looks most like is choice D for me. It kind of looks like a parabola that opens up on the right and a parabola opens down on the left. Make our selection and check your answer. And then let's talk about the range of the function. Again, the range is the y values. Look at the y values. What do you think the smallest y value is that you're going to get out of the table and the largest y value that you're going to get out of the table? And when we look at the range on the graph, we want to look low to high. What is the lowest that this graph is going to go and the highest that this graph is going to go? Well, this graph keeps going down, down, down. It's going to go down to -infinity, and it keeps going up, up, up to +infinity. So our range is -infinity is the lowest that this graph is going to go to +infinity. That's the highest this graph is going to go. Let me check our answer. -infinity to infinity. Good job. Now I'd like to show you how you can graph some of these on a graphing calculator. Going back to question number 1, which one is the graph of the function y is equal to x squared and what is its domain? Well, on your graphing calculator, you want to turn the calculator on and press the y equals button. Make sure everything is cleared, including those plots, and the y is already there, so we're gonna type in the x squared. I use this button for x and this button for squared. And then I always start off with a standard graph by pressing zoom and start with number 6, the standard zoom. You see I have a graph that looks like a parabola, much nicer than my hand-drawn graph, but you can still see. Another thing you can do is actually trace, and you see um, when it traces, you see x equals 0, y equals 0. That's one of the points here. I can double check here. I can type in -2 for the x value, and you'll see when x is equal to -2, y is equal to 4. And another thing you could do is actually look at the table of values. I'm going to go to press second table, and you begin to see part of a table here, 0, 1, 1, 2, 4, 3, 9. So there's actually a lot of different things that you can look at in terms of using a graphing calculator to sketch a graph. I typically go to the graph and use the trace feature. Let's do the same thing for number 2. How do we graph y is equal to the absolute value of x? Well, on your graphing calculator, you locate, again, turn the calculator on, go to the y equals button, clear what's there, and this time we're going to type in the absolute value of x. Now there's no vertical bars here, so we have to find that command in the math menu, and we use the arrow to the right to find the NUM, which stands for number, and we're going to choose number 1. ABS on the calculator will actually either show ABS on your calculator or actually show up the vertical bars. Then you can type in X. You can move the arrow to the right. So you have Y is equal to the absolute value of X. And I like to do the zoom standard to see the sketch of the graph. You see a nice V graph. And the third one, how we sketch the function y is equal to x to the third. Go to the y equals, I'm going to clear what's in there, and then we're going to go x, raise it to the third power. Use the arrow to the right, and again we can go to a zoom 6 so you can see the sketch of the graph. And you can go to second table to view the table, and there are ways that you can adjust the table settings. Have fun!